A very good evening to all of you who have gathered here today to witness this special webinar titled Chemistry for Social Conscience, organized by Section E2 of the Sri Lanka Association for the Advancement of Sciences. On behalf of SLASS, Section E2, it is my great privilege to welcome our speaker today, Professor Ravi Silva, who has joined us from all the way from UK to have this very timely presentation to our delighted audience. So without further ado, let me introduce the speaker to the audience. So Professor Ravi P. Silva is a distinguished professor and the director of the Advanced Technology Institute at the University of Surrey. He joined Surrey in 1995 after completing undergraduate and postgraduate degrees at the prestigious Cambridge University. His research interests include nanotechnology, large area electronics, and renewables, and has resulted in over 650 presentations at conferences and over 600 journal papers. He has over 23,500 citations with an H index of 76 and has won research funding in excess of 40 million British pounds. He is the inventor of 40 patents, including key patents on low temperature growth of carbon nanotubes, fabrication of high performance large area X-ray detectors, and fabrication of large area nanotube organic solar cells. He is also a fellow of the Royal Academy of Engineering UK and a fellow of the National Academy of Sciences Sri Lanka. He was made a commander of the Order of the British Empire in 2021 Queen's New Year Honours list, just 1 year back. So without further ado, it is my great honor to invite Professor Ravi Silva to speak about energy transitions to cleaner and greener technologies. I believe it's a very timely discussion. So once again, thank you very much, Professor Ravi Silva, for accepting our invitation. So without further ado, let me hand over the controls to you to take over, sir. Over to you, Professor Ravi.
Thank you, Lahiru. Thank you very much for that introduction. And let me start off by really thanking all of you for attending this talk in this very disturbed period of time in Sri Lanka. I am highly appreciative and conscious of what is happening in Sri Lanka. And we did discuss whether we should carry this on with all the different problems currently, but thought it would be appropriate to continue with our academic pursuits, because at the end of the day, as young leaders going through the system and showing academic leadership and science leadership is very important in times of chaos. And therefore, we decided we should go through this. The title itself is extremely pertinent, Chemistry for Social Conscious. It's because energy really is at the heart of everything that we do. And as a result, I was delighted to be invited by Lahiru to talk about energy transitions and how we can certainly go to a greener and cleaner technologies. What is very important also to realize is that change happens generally when you have erudite, knowledgeable audience who are willing to change. Sometimes that sort of change can only happen when people are willing to listen and have open minds. And this is why it's very important for the younger generation coming through to make sure that they realize you can do anything in the world if you want to. You just have to have the will and the abilities. And I think it's up to policyholders and policymakers to make the environment suitable for you to develop. So from getting into my discussion, I'm very happy for people to ask questions, but I'm going to try and target to finish in about 45 minutes, leaving times for questions. Before starting, I'd just like to thank a number of group members who have helped prepare some of the slides. And these include Imaka Javardhana, who's been with me at Surrey for over 10 years, Shashini, Ashini, Ravi Mishra, and Kia Gandhi, who've all contributed to getting these slides ready. Um, a very, very quick overview of the Advanced Technology Institute and the work we do. So the blue building that you see here in the background is the Advanced Technology Institute. We have about 160 researchers doing various activities on technologies of the future. And one of the key aspects that I ask people when they join the Institute is that come here if you want to dream about changing the world. The whole idea here is we will provide every facility possible for you to be able to make a difference in the world. And that's all I ask from researchers. So we have about 60 PhD students and 80 with the attached PhD students who work on cutting edge activities. And the reason I mention PhD students and postdocs in particular is that that's where the revolutionary ideas generally come from. And we are very much there as academics just to guide people with much of the work coming through our student population. We were lucky to get the Queen's Anniversary Award for our activities at the Advanced Technology Institute. And as a university, we are pretty well known in satellite technology and water research. And I thought I'd show you this image at the bottom left, which was a building that was created for the last Winter Olympics in South Korea. And what is special about this is that this was called the blackest building on Earth. And it was the blackest building on Earth because it was covered in a material called Vanta black. Vanta black was invented at the University of Surrey, and it's sold by Surrey Nanosystems, a spin out of that activity. And what is very, very important there to realize is that we can apply it on large areas and in buildings such as these, but the properties come because of the nanoscale structure of the material. So change can happen as long as you have many, many people, many materials working in the nanoscale collectively to be able to deliver a particular message that is needed. Now, we do live in times of change. And if one were to say 10 years ago that a city such as London, and this is Piccadilly Circus in London, one of the most cosmopolitan, busiest cities in the world, could move from that to an image such as this overnight, one would have said that is not possible. To take an airport that is one of the busiest airports in the world in Heathrow and move from that to something that looks like that. Now, this all happened because of the COVID epidemic that we are all suffering from. And it happened because of changes in the environment, changes in the manner in which we live. And these are man-made changes that have given rise to significant variants that are now affecting all of us. In fact, some of the problems at the moment in Sri Lanka also stem from COVID-related issues on travel restrictions. This also affected universities, and I did my undergraduate and postgraduate work at Cambridge. And even, in fact, I was in Cambridge on Friday because I attended a function there. And still, the university has not fully recovered and got to the number of students attending lectures daily, simply because of the implications of change that is taking place. Now, speaking of the change, clearly Sri Lanka is not immune to change. And what has happened in Sri Lanka also needs to be considered in its context. But what we should realize is that the natural resources that are available in Sri Lanka are second to none. And what I've shown here is effectively some of our natural resources that are as a result of the Mahavalley that flows through various geological features that gives us waterfalls. And in some of these cases, if you are able to have a bund and create a dam, this allows us to create hydroelectricity. And this allows Sri Lanka for the last 50 years to have one of the most developed hydroelectricity activities in the world. So it's interesting, in the 50s, 60s, and 70s, we had nearly 90% of our energy generated through the hydroelectric system that was developed. And even in the 80s and 90s, this was something like 80%. Unfortunately, despite having all of these wonderful resources for energy generation, we have not progressed significantly in that area. It also emphasizes in the theme of changing world that we were once the rice bowl of Asia. And now we need to also be cognizant of the fact that in terms of solar energy, Sri Lanka being close to the equator has a huge natural resource available to it. And in moving forward, we need to be able to take into account this sort of activity. Unfortunately, despite all of these resources and particularly the energy activities, we've come up to a point where there are unrest associated with energy problems in the country and other activities that are not due to the resources that we have, but poor governance. And that's something that we really should not allow as people of a country that has so much natural resource. Unfortunately, the bottom line in the world today is that man-made changes are impacting everyone. And in some cases, those man-made changes really are to the detriment of society and its operations. This whole of negative of the world in thousands of years. So if you take the present as your 0 point, for the last 10,000 years, the temperature of the world has been between plus or minus 0.5 degrees. So the total variation has never exceeded about 1 degree. Unfortunately, in the last 50 years, the amount of change that has been man-made has been so significant that this flat temperature profile has moved from plus or minus 0.5 to now up to plus 1.2 degrees in comparison to pre-industrial state. So man-made changes are making a significant impact on the environment we live in. This is because we all want to become more and more developed. And in wanting to be more developed, we are dependent on energy. And unfortunately, the energy that we use is the wrong type of energy at present. In addition to that, there's a lot of pollution out there, and that pollution is also creating problems in the environment, such as the seas, etc., that is giving rise to climatic changes. So these changes are bringing unthought of consequences to the world around us. And in fact, from a geological sense, we've now gone from what we call the Holocene period, which was the last 10,000 years, to the Anthropocene age. And the Anthropocene age means that there is more man-made changes around us than anything that is naturally found. And this is because of the insatiable appetite of the humans to be able to develop things using different types of energy sources. Now, thinking of the post-COVID world, we always knew things had to be different. So thinking of Sri Lanka beyond its current issues also is something that we have to start considering. And in considering such a world, we know that if we do not look after our environment, the consequences could be far more severe than what we've seen during the COVID period. We need to start thinking better, thinking smarter. We need to be able to start developing new technologies that are using less energy. And we need to start thinking of new smart technologies that can be used in getting to this point. Now, the Bank of England head, Mark Carney, indicated that if we as a world do not look after our climate, the climatic change that comes could be far worse, or nearly 10 times worse than the current COVID crisis that we've been through. So again, what you note here is the impact of us not looking after our world and our environment is significant. And that's something that from COP21 onwards, from the Paris Agreement, we all agreed needs to be looked at. Now, the reason we have this problem is associated with the energy mix that we are using. We keep increasing the use of energy. And if we take the energy use 10 years ago, 2010 in the US, you can see typically 80% of the energy comes from coal, petroleum, and natural gas. So this is a developed country. Now, if someone says, well, that was nearly 10 years ago, if we look at some of the more recent figures, 2017, if we look at 2020, again, you end up with this 80% dilemma, that nearly 80% of energy currently used is associated with fossil fuels. Unfortunately, the renewable, truly renewable part is very small. And if you look at just solar and wind, that's about 2% of the world energy use. There's about 3% of hydro, then bioenergy of 10, and nuclear 5 from a world perspective. So this is an article that I wrote with regard to where we are from a materials energy point of view in a journal, Energy and Environmental Materials. I'm the editor-in-chief there, and I publish this editorial saying that it is about time we as a world looked at changing this 80% fossil fuel mix. Unless we do that, the consequences are significant. One of the main consequences of using fossil fuels is the increased CO2 use. And if I look at pre-COVID period, the full pre-COVID period was 2018, there was around 37 billion tons of CO2 emission coming out of purely fossil fuels. And this is 27 billion tons too much for the world to keep up with. I'll say more about that number. But if we were to look at the CO2 emissions, which are shown here in this graph, together with the temperature rise. So the CO2 emissions are shown in the blue curve, where in 2000 it was around 380 parts per million. At the present time, it's about 420 parts per million, 416 actually. And what you see is this coincidence between the CO2 emissions, the blue line, and the average temperature that we see around the world. And after about 1950, because of mass industrialization, this increase in temperature continued, and that has continued on. Beyond that, if you look at 2020, It's now at about 1.2 degrees. Now, for those of you who have followed COP26, which was held in Glasgow, and from COP21 onwards, what we've said is that if the world does not stop the increase below 1.5 degree by 2050, the consequences will be catastrophic. And unfortunately, this is happening. Within the UK itself, we had 3 storms in 1 week last month. And these storms are becoming unpredictable, they're becoming dangerous. In terms of the Arctic and the Antarctic, huge amounts of glaciers are melting. And when Mexico has 1.5 meters thick carpets of snow falling during summer, you know there is a problem. So the number of unpredictable extreme weather events that are taking place is unprecedented. All of this is associated with the fact that we are far away from net zero. And at the moment, there is 37 billion tons of CO2 emitted in the world, and we are only removing roughly about 10 billion tons. So there's 27 billion tons too much. So by 2050, we need to go to a point where the anthropogenic greenhouse gas emissions are equal to the anthropogenic greenhouse removals. And unless we do this, the problems are going to be very, very significant. Now, moving to Sri Lanka, if you look at the Sri Lanka population and where it's distributed, so that's the map shown here on the right. And then we look at the amount of solar energy that we get on the left. What you generally see is in areas where there is high density of people, there is also pretty high density of solar flux. In fact, the solar flux is to the level that you can get significant amounts of energy from that. And I will show you some maps as to the numbers I have worked out with regard to how much energy we can get. And in order to get that amount of energy, how much space we need. I will also cover the cost of solar energy in comparison to other forms of energy typically used in Sri Lanka. And if we take the total amount of energy used in Sri Lanka in this pie chart shown here, typically hydro accounts for about 40%. We have about 10% of other renewables, wind and solar, with nearly half the energy being associated with thermal coal and thermal oil and gas. The problem Sri Lanka has in this particular scenario is the fact that Sri Lanka doesn't have coal, it doesn't have oil, it doesn't have gas. And we keep buying coal, oil, and gas at significant cost to the foreign reserves of the country in order to provide the power. And this is something that we really need to try and remove if we can run the country without that. Now, the idea of running the country with renewable energy and reducing the coal and oil has been around for a long time. And if I just take some of the more recent reports that came out in the last 5 years, there was this UNDP report that said Sri Lanka has the possibility of running the country with 100% electricity generated by renewables by 2050. In the review that it did, it looked at all of the energy statistics that was there for Sri Lanka until about 2016. And when it looked at it showed quite clearly that Sri Lanka, unlike other countries, had about a third of the electricity used for domestic, a third for industrial, and about a third used for commercial purposes. So this is pretty normal. And what it meant was that if we can have 100% electricity generation in the country through renewables, it means that we could cover the domestic, the industry, and the commercial activity. It also predicted that, based on its analysis, that there should be an average growth of about 6% per annum of the electricity use. And based on this, it came up with these scenarios that you could come up with a scenario where by 2030, nearly 75% of the country can be renewable energy based if you followed a suitable plan of developing particularly the solar energy part and the wind energy part. And by 2030, you could come to a situation where only 25% was fossil fuel based. So that is moving from nearly 50% at present to 25%. It also said that this mix by 2040 could be reduced to less than 20%. And by 2050, we could really have total renewable energy for electricity. Now, what we do know is since 2015, that has not taken place. And one of the reasons there are power cuts, unfortunately, in the country at the present time is the fact that we are using foreign reserves and dollar accounts in order to buy coal, oil, and gas. I did an analysis of the electricity in Sri Lanka in 2015, and I looked at the numbers again in 2018, and the full numbers that I got was the 2016 numbers. And this all comes from the report that was done by the Ceylon Electricity Board called the Least Cost Long-Term Generation Expansion Plan. And roughly speaking, all we need to look at here is the fact that the total renewable in 2015 was about 2 gigawatts of energy, and the total that was based on fossil fuels was about 2 gigawatts. So roughly 50-50. And whether it was 2015 or 2016, those numbers were approximately 15%. It also showed that you have a maximum peak demand of about 2.5 gigawatts. And if you can cover a peak demand of 2.5 gigawatts and get a total electricity supply of 4 gigawatts, you could be able to run the country totally with renewable energy sources. Now, if I look at the newest figures I could find, and this is a few months back in February 2022, and if you look at the renewable energy at the moment, what it's showing is that your renewable energy that includes hydro is at about 1 gigawatt. And your fossil fuel use is about 1.5, 1.6 gigawatts. So we are not even doing the 50% of energy from renewable sources, with fossil fuels dominating the energy in January, February, typically when hydro is not as high. The peak demand is still about 2.5 megawatts. So somewhere between 2015 and 2022, things have gone so badly wrong within the energy supply area that even the typical 50% of energy is not coming from renewable energy anymore. Now, if we look historically at the energy mix that we've had, and he's going back to roughly 2000 for the last 20 years, what you see is in 1998, nearly 80% of our energy came from hydroelectricity. That number of total power generation of 4,000 gigawatt hours has continued almost within the error bars to the present time without having any major expansion. Since 2000, if you look at oil generation, that also seems to be either at that level or double that level and continued. From 2010 onwards, we've had significant coal generation coming in and then other renewables. So whatever policy that has been followed by the government has meant that from 2000 onwards, we have not developed our hydropower plants, which was giving us 80% of renewable energy. We've increased somewhat of our oil generation, which is probably the most expensive form of electricity. And what we've done is we've added coal when everyone else in the world is trying to reduce their coal usage. So somewhere or the other, policy-wise, we've done something very different to what is expected. And as a result, the consequences are that the power generation at present in the country is expensive. It's probably one of the most expensive in the world, unfortunately. What is even worse is that within the 2018 plan put by the Ceylon Electricity Board, within this least cost long term, for the next 20 years, the proposal was that we will have another 50% of new energy, roughly 4 gigawatts of renewables, and another 4 gigawatts of fossil fuels. Now, this seems to me ludicrous, because why would you, knowing the problems associated with coal and oil and gas, keep increasing your fossil fuel-based technologies? I did see a report about a month ago that indicated that finally the government of Sri Lanka have recognized the fact that solar electricity at present is cheaper, much cheaper than oil or gas, and that we should change. So hopefully, once stability comes back to the country, we will go back to greener technologies that are clean, based on solar and wind, rather than going back into oil, gas, and coal. My recommendation any day would be that we really need to stop increasing any of these capacities today, and I'll tell you why. So if we look at the solar irradiation that hits Sri Lanka, typically on average annually, we have about 5.5 kilowatt hours per square meter. Now, if I use the statistics associated with the UNDP report and examine the total amount of energy the country needs for the next 10 years. So the UNDP report was 2015. So I used their projections of the total amount of energy need. And I say, let's do a Gadakian experiment, of a thought experiment of how much space would we need if we were only to run it on solar. Now, you would never run a country only on solar. You will always have wind and some amount of backup energy. And in this case, our backup would be hydro, because we had hydro that was giving nearly 80% of our energy. So if we looked at this experiment of saying, if we only wanted solar energy to run our total electricity bill, what this graph shows is the amount of area that you require depending on the type of solar module you get. At present, typical solar modules work at about 20–22% efficiency. But say we get cheaper amorphous silicon solar cells that are 14%. Even with 14%, you're talking about square areas of between 40 square kilometers to about 100 square kilometers. If the module efficiency was at 21%, you're talking about something around 25 square kilometers to about 70 square kilometers. Now, in a talk that I gave to the National Heritage in 2018, what I proposed was that you needed to have 10 solar parks in Sri Lanka, each giving a capacity of about 100 megawatts. And if I had 100 megawatts at these 10 points, and again, I selected the 10 points depending on the population and the amount of solar irradiation that was got. So these were purely hypothetically chosen areas. This amount of increased solar electricity capacity was enough to power the energy that we were getting from the fossil fuels. If we want to have a total of 2.5 gigawatts of energy, you need roughly that area. And what you see is that area that you see in the diamond needs to be found based on the country's land. And what I can show you is that that area can now be found even with floating solar in some of the big samudras that we have, without even going down any irrigation or building-based solar activities. Now, the government did come up with a plan, and they came up with a plan 2 years ago that they said they wanted to have 200 megawatt systems in Punarin and Monaragala. If I compare that to what I had proposed, I had said Kirinochi, they said Punarin, which is close enough. And similarly, one of the places here was Lahugala, and they've got Monaragala here. But just having 200 megawatt systems is not enough. We need to have 10 times that amount if we really want to remove the monies that we are spending on oil and gas. If we want to look at it purely in terms of space, and we want to look at it, what's the amount of space we need by 2050, again, assuming that the module efficiency can go up to 30%, the additional space area that is required is probably less than 0.5% of our land. So we really need to start thinking differently to previously, where people said, oh, the amount of land that is needed for solar is not feasible. If we were to start thinking about these as floating solar, just the Mineria tank has about 20 square kilometers, and the Sedanayaka Samudra has about 90 square kilometers of surface area. So there is nothing to stop us using that if we do not want to use other land that can be used for farming. Now the question is this really feasible funding-wise? And let me just go to those figures because I think that's important. For some reason, some of the slides have got mixed up. But first of all, from a worldwide perspective, let me answer the question, is there enough solar energy to solve the problem, right? If you start thinking of what sustains life on Earth has been sustained throughout by solar energy. So whether you're looking at crops that have been grown through photosynthesis, so your hydrocarbons being created with the chlorophyll in your plants, giving rise to the energy that we need, or whether it's coal, oil, or gas that has been dug out of the ground by fossilized solar energy plants, etc. At present, all of our energy needs are met through energy that came directly from the sun. What we need to try to do is to go through that direct connection of photons to electricity rather than any of these fossilized routes. And this is possible with some of our technology. And one of the key things that we want to try to do is to have technology that is versatile. And when you think of the most versatile form of energy use, that would be electricity, simply based on the fact that whether it's for a household or industry or even transportation, electricity can provide the necessary form of energy that can be easily produced using green technologies. Now, if you look at the cost of it, what this view graph shows is the cost of the different forms of energy, and these US dollars per kilowatt hour. So until about 2020, the cost of solar, wind, whether it's offshore or onshore, was still higher than typical fossil fuel costs, which was in the range of about 4 cents to around 15 cents. Within the paper that I have just written and published using data available in the public domain, what I show is the cost of solar, which is shown in green, and the cost of wind, that is shown in yellow, has come down drastically. So the green line shows the cost of solar has plummeted down. Similarly, the cost of wind is shown in yellow, has reduced significantly, but less so more recently. And conservative estimates show that that cost will continue to decrease. Now, if I compare that cost to a gas combined system or a coal system or a nuclear system, here's a log plot of cost, levelized cost of energy. If solar and wind is at present at around 30 US dollars, 30 US dollars is effectively 3 cents per kilowatt hour. Your gas will come at 4 cents per kilowatt hour. Your coal will come at about 7 cents per kilowatt hour, and your nuclear at about 10 cents per kilowatt hour. My predictions are, with the current rate at which efficiencies are being improved in solar, your energy from solar is going to continue on this trend. It's not going to plateau off. And as a result, we will soon be seeing energy at less than 2 cents or even 1 cent per kilowatt hour coming from solar energy. Now, if you look at the world as a whole in terms of new deployments, solar energy takes around 50% of all new deployments, of onshore wind about 30, offshore winds about another 10. So nowhere in the world are they putting nuclear or coal or gas plants. What they're putting are renewable energy technologies. Unfortunately, Sri Lanka's expansion plans are saying we want to have 4 gigawatt power capacity put on fossil fuels. So this is something wrong with the policy that really needs looking at. I've also written a report that actually has been taken up with the UK government, which is business, energy, industry, and skills, and where they show this data very clearly that large-scale solar and onshore at present in the UK is lower than offshore wind, combined gas, nuclear. So for a country that has a latitude of 55 degrees, the amount of solar energy we get is far less than what we would get in Sri Lanka. So in Sri Lanka, if I did the same comparison, the cost of solar will be way below this. But even in the UK at present, large-scale solar and wind are the two cheapest forms of energy you can get. So for Sri Lanka to say it's cheaper for me to get coal energy or gas turbine energy is ludicrous. There's nothing in the evidence that says that is correct. So the whole idea of Sri Lanka going into 80% renewable plan, which is something that was talked about, certainly needs to be done. We do need to take into account the intermittency, but because of Sri Lanka's beautiful geology, it means that we can use pumped hydro to use as your base load. We need to have a base load of 2.5 gigawatts of energy, and that 2.5 gigawatts of energy can nearly be supplied totally with the hydro. And if we have a further 2.5 or 2 gigawatts of renewable energy with wind and solar, it means that the total country's energy needs can become secure, and we'll have energy security and need not go external to buy fossil fuels in order to save things. So whatever we do from a solar energy point of view, we also need to think of having the storage, and pumped hydroelectricity would be the perfect system for us to go. Now, interestingly, we have looked at some pumped hydro activities also. And in a project I have with India, in a village called Ravi, we've looked at pumped hydro, and we can get efficiency gains even when we have a head height of 2 meters with current hydropower. So that means that actually Sri Lanka's hill country is absolutely perfect, but you don't need to go to the hill country to get energy storage that is efficient. Even a head height of 2 meters is enough. And typically in Sri Lanka, you can get anything up to 5 meters, even in the coast, if we want to have small scale pumped hydro. So trying to bring everything back together, if Sri Lanka really is to become a sustainable nation that follows the sustainable development goals that have been agreed through the UN, we certainly can do that. We have the right environment to be able to do the clean and affordable energy. And with that, hopefully we can start looking at clean energy, quality of life, and other activities. I think as a group of people, Sri Lanka are very proud, and we have a great heritage. We need to think about what is this heritage that we can hand over to the next generation coming through. And in countries, places like the Great Barrier Reef can be seen as a heritage. It could be the white lights associated with the northern lights. But in Sri Lanka, maybe energy is something that we can say is a hereditary right of all people. And much like water and air, we need to probably say light can be used and used as a free energy source for our people. So let me conclude by saying the sun is really the source of almost all energies that are being used, even the fossil fuels, although that was created many, many thousands and millions of years ago. Energy does allow us to have a higher quality of life, and Sri Lanka, more than others, have a great potential to have a mixed hydro renewable energy system. 80% of the current energy system is based on fossil fuels, which we need to change. If we can go into technologies that are suitable, that are much cheaper than technologies out there at present, we will be going to green energy technologies, which Sri Lanka can act as a test bed. And at the present time, we really need to have the educated people and the Ceylon Electricity Board and other power generating people back us to go down this solar electricity pathway. So with that, I thank you for your attention and I look forward for any questions. So over to you, Lahiru. Thank you very much.
Thank you very much, Professor Ravi. And that was a very delightful presentation, I should say, that basically sums up where we are as a nation right now. So thank you very much for that very beautiful analysis as well, sir. And as you said, the floor is now open for any questions. So if anyone in the audience have any questions, I believe Professor Ravi would be happy to answer those questions. And let me remind you, you may use the raised hand option in Zoom, and I will prompt you for your questions, or instead you can also unmute yourself and present your question to the audience, or else you may even use the chat option to present the questions to the audience. So I believe the floor is open. So is there any questions from the audience?
Just Lahiru, before my power goes off,
Yes, Professor.
I'm about to have a power cut very soon, so I better talk and get out. Thank you very much, Professor Ravi Silva, for your enlightening talk. I think it is very timely at a time that we are going through. So my question is that, just because this is green, how sustainable they are, like the materials that we use and the cost-wise, and how it can be made sure that it is uninterrupted. Because what happens in our country is we come up with a grand big plan and suddenly something very small happens, and then if it gets interrupted, then we abandon the whole thing rather than studying where we went wrong to fix that. So we have to make sure that it doesn't get interrupted. So maybe I won't be there for the answers, but you can go on, sir.
Okay, no, thank you very much for the question. It is very correct and a very well thought of question. We definitely have to have sustainability. And you're absolutely right. We need to think of the grid. At the moment, the grid as it currently stands probably is not perfectly situated to be able to take any large quantity of renewable energy. So we need to start thinking of smart grids with much more localized energy supplies. And within that's why I said that we need to start thinking of much more localized pumped hydro that allows us to start thinking of delivery in different regions rather than thinking of a single grid system, but much more smart grid that allows us to do so. Now, is it sustainable? I would say solar is probably the most sustainable of these sources. And in terms of life cycle analysis, even compared to wind, where you have to build big turbines that are using energy in order to produce your turbines, your wires, and all the mechanical parts, in the case of solar, the amount of energy you need is far less. Now, in addition to that, what we are looking at is next generation organic, inorganic solar. Now, I didn't talk about that because it's not something currently available, but we can produce energy at probably 1/10 of the cost of silicon solar now by using our organic compounds. But the reliability is not quite there. But with silicon solar, there is 25 years or more of guaranteed supply. So as long as the intermittency associated with being able to switch between your stored hydro and renewable energy, whether it's wind or solar, is there, it can be done. And that's something really part of the grid system and national supply that has to be looked at.
Thank you very much.
Sir, I have a question about the e-waste which is being generated with these solar panels, because now we are just like putting the solar panels everywhere, but after like 20 years, those are going to be like the e-waste. And then is there any solution that people are thinking about how to dispose those or how to recycle those?
a very good question, Amil. Again, this is exactly what we need to do now. And that's why I said that whole life cycle analysis becomes very critical and the carbon footprint becomes critical. At present, the smallest carbon footprint you can get is solar. So the amount of e-waste is much smaller in solar in comparison to other technologies that are on the renewable end. But we still need to think of good ways of getting, removing solar panels and recycling it. So a lot of the solar panels that you get can be recycled, because typically you're talking about silicon here. And silicon, if you heat it up to 1500 degrees, can be changed back into nuggets and used. So again, you can create that. We don't have a perfect infrastructure to do that yet, but it is something that we really should be doing, because again, silicon is a very scarce commodity when it comes to high quality silicon, which is what is used for solar panels, but the highest quality of silicon typically is used for semiconductor industry. So we need to think about it. And the energy wise also, the amount of energy that is used with recycled silicon would be probably a quarter of the energy that is needed to make silicon solar cells from silica or glass.
Okay, so thank you.
Thank you, Professor Ravi, and thank you, Dr. Amila, for that question. So I have a question myself as well. So you spoke about how we can use solar cells on top of, let's say, forests or mountains or any other environmental terrain. So what kind of impact would that have if we, for example, if we have solar cells on top of a mountain covering a whole large area of plantations or whatever? What kind of an impact would that have on in the long run, sir?
So it's a good point, right? I didn't say we need to cover anything at the moment. So technically at the moment, there is enough space only on the water. So if we just take the Parakrama Samudra, the Siranayaka Samudra, the area of the water tanks are big enough to have enough power generating capacity to run the country. So it's actually double efficiency, because by having solar panels on top of your irrigation network of lakes, you stop the evaporation also of water. So you reduce the evaporation of water, you probably reduce the amount of green algae that is going to be created within the lakes that have to be created, removed, and sifted. Now that's one option. Now your point on it will not only be there, there will generally be some put on other areas also. Now, when you start putting on other areas, typically what you would like to do is to use desert areas to do this rather than areas that can be used for agriculture. So you would normally never use it for areas that have agricultural plantations. You'll use it for other areas. Now, doing so, you do not need to have solar panels at ground level. You can raise it up. So for example, in the UK, the newest solar plant that has come in is called Cleve Hill. And in Cleve Hill, what we are doing is we are putting the solar panels at 2 meters above ground. And for the 2 meters above ground is that we can then increase the biodiversity underneath the solar panels. So what we've been able to show in this 350 megawatt power plant in Kent is that we can increase the biodiversity by about 64% by controlling the area around and creating new species that can work underneath the solar panels rather than anything else. But absolutely not to cover agricultural plantations, because that would defeat the purpose of the idea.
Definitely, that answers my question, sir. Thank you very much. And one more question, sir. You spoke about the distribution of the different power sources like renewable energy, hydropower, and all, coal power, and all that. How does the distribution in Sri Lanka right now compare to UK?
So the UK, very luckily, has now gone completely out of coal. So at present, it's zero coal.
Wow.
Now, from a country that started completely 100% dependent on coal 150 years ago, to go to zero, we've shut down all our coal mines. So it's a very positive thing. Now, if you compare it to Germany, where people think Germany is a highly sustainable system, Germany has about 10 gigawatts of coal power plants still. They have no nuclear, but they have coal. UK about 15% of nuclear at present. We have hit about 25% of wind and solar now. And the rest is typically coming from oil and gas. So we still need to move because our target from UK point of view is that there will be 30% from renewables. And by 2050, there'll be 50% from renewables. So there is a plan, and the economies and energies that are needed are much greater. So we have to work more slowly and things take time. But certainly UK doesn't have hydro. If we had hydro, this would have happened very, very quickly. And I think this is where if Sri Lanka in 1998 had 80% that was hydro and we continued that, all we needed to do was to grow that hydro, increase the efficiency, and provided there was still the monsoon rains that came. But the problem here is we keep using fossil fuels, we put more CO2 out there, that changes the weather, that reduces the rainfall. So it's a very, very bad cycle that you have. And so maybe if a lot of countries had not gone down fossil fuels, we still will have large amounts of rainfall, we'll have 2 monsoons, and there will be enough energy to run. But Sri Lanka could have easily increased its capacity of hydro. And as I said, we don't really need very tall areas in order to put large bunds. You can do much smaller. And there's a lot of private companies doing very small hydro activities. So Sri Lanka has a lot of heritage. Lanka does a lot of activities associated with small hydro and wind. So these are the companies that we really need to back to try and connect up to the grid so that they can be properly linked. Because I think still there are problems with linking some of these smaller scale hydro and wind to the national grid. And that has to change.
Thank you, sir. That definitely answers my concern. And that's definitely an eye-opener, especially because for UK to go in the exact opposite direction, starting with 100% coal power and now completely going green, I think that's definitely where we should be looking at in terms of our country's future as well. So thank you very much for that very nice analysis, sir. Are there any other questions from the audience? So I do have one more question, if I may, small question. You have in your presentation, your main focus was on solar energy and how solar energy can be used for our country. But at the same time, I know that there's a lot of research going on in terms of much more sophisticated ways of generating electricity, maybe like hydroelectricity or all these high-tech advancements of energy generation. What potential do we have in Sri Lanka to embrace these new technologies rather than just looking at solar, which we have tried to do over the last 10 to 20 years, I would say. But then these new technologies, do we have any way of implementing those in Sri Lanka?
Absolutely. I think Moratua has already started a lab associated with Triboelectronic, and one of my former students, Ishara Dharmasena, is doing a wonderful job in having a joint activity. He's at Loughborough now, but he's doing some work in Moratua also. I think there's a lot of scope in using triboelectric and piezoelectric energy. The reason I didn't talk about that in particular is because that is for much smaller amounts of energy. So if you are thinking of your local IoT, Internet of Things devices, if you want to have wireless autonomous sensors, if you want to have systems that are on buildings that are powered with indoor energy sources, you can use that, but they cannot be used for large scale power generation at present. So for small scale, it certainly can be used. And to answer your question, does Sri Lanka have the infrastructure to develop it? I think with its textile industry, it's probably perfectly placed to start using different types of fiber to generate tribo energy or static energy and use that to start looking at 24/7 measurable biopotential garments that can be given to people, as long as you don't increase the static too much to have a little shock yourself. I think it will be fine to be able to develop self-powered systems. So there is a huge potential, and it really needs to have young minds thinking new ideas in the right way in order to proceed down that route.
Thank you, sir. That's definitely very encouraging to hear that we do have the potential to do those things here in Sri Lanka. I mean, we are looking at various ways of implementing research in these areas, and hopefully in future we will be able to implement at least some of these new technologies in Sri Lanka. Before we wind up, do we have any other questions from the audience?
Lahiru, I just have a simple question for Professor Ravi. Sir, is there a way we can enhance the lifetime of those solar panels using new technology, for example, by coupled with nanotechnology?
Absolutely. I think it's a very good question again. And now one of the key things that is going to happen in the next generation of solar panels that come is going to be not just silicon solar, but they're going to put a perovskite layer. The perovskite layer that's going on top of the silicon is only going to be about 2 microns thick, but it's going to enhance the solar panel by probably about 3 to 4%. So instead of having 22%, it will go up to 25, 26%. Now that's by having an extra layer. Now, from a Sri Lanka point of view, we can also start thinking of what anti-reflection coatings we can start putting on these things, because every time you have an interface of light, there's a 4% reduction associated with reflections. So if you can reduce the amount of light that gets reflected and have a gradually controlled refractive index, you can start improving the light coupling. You can also start improving the light coupling by having plasmonic surfaces, so different types of metal or other nanoparticles on the surface that will get better light coupling. And also you can have self-cleaning glass. So again, like the Lotus effect, you can start making packaging that is better. So there is a significant amount of new work that can be done, but it does need to have solar energy companies involved so that you can test your technology on top of it. So yes, definitely there is promise there.
Thank you, Professor Ravi, for that answer. Dr. Ivanka, do you have any more questions?
No, thank you. I said thank you. Right. Okay.
Thank you, Ivanka. Okay. So seems that there are no other questions from the audience. So now, behalf of SLASS section E2, I would like to take this opportunity to thank Professor Ravi Silva once again for joining us amidst your very busy schedule, sir. And I mean, thank you very much indeed for understanding the situation, because yes, just yesterday, I tried to explain to Professor Ravi about the situation back in Sri Lanka, and obviously we didn't expect a large crowd to be here today, especially because of the power cuts. And so thank you very much, Professor Ravi, for accepting our invitation and understanding the situation. And we are very sorry that we didn't have a large enough gathering to hear the delightful presentation that you had. But we have recorded the entire presentation, and we will host it up on SLASS YouTube as well as the SLASS webpage. So therefore, it will definitely be available for a much wider audience, which I think is something that's very, very valuable, because as I told earlier, we have done a very nice analysis, a very nice presentation of our current situation. And with the suggestions that you have made, with the actions that you have proposed, I'm sure Sri Lanka will definitely have a brighter future going forward. So once again, thank you very much, sir, for being here amidst your busy schedule, and we look forward for your cooperation even in future. And let us all collectively hope that the suggestions will be well taken, and with that we will still have the hope of having a better tomorrow. And I would also like to thank Dr. Chamila Kadigamua for helping out in coordinating the event, and also all my fellow Section E2 committee members for being here, and also with assisting us in coordinating the entire event. And last but not the least, I would like to thank all of you for being here. I know that most of you would have been in a power cut at some point of time. I'm sure some of you might even have power cuts later today, but amidst the busy schedule, amidst the very, very tight situation, thank you very much for taking time off to being here with us, because I'm sure there's a lot to take home from this very valuable presentation. So thank you once again. And before we wind up the presentation, I would like to make one request. Our association have been greatly limited to a virtual platform because of the COVID situation. But as a souvenir of our event today, I would like to request anyone who has access to a cam to turn on the camera so that we can capture a picture of all people in the audience. So I would like to request anyone who has a webcam right now to turn on their cameras, if you can, so that I can capture a souvenir. Let's see. Okay, one more time. Okay, looks fine to me. Thank you very much. Okay, so with that, we have come to the end of this presentation, Chemistry for Social Conscience. So this, once again, as we mentioned at the very beginning, is a series of webinars. This is the very first webinar that we organized for this year. So thank you, Professor Ravi, for accepting our invitation. And we hope to have more webinars under this theme, Chemistry for Social Conscience, because as scientists, we believe that science has a lot to say and a huge role to play in terms of social conscience, especially at times of social distress. So therefore, whenever something comes up in terms of having a social impact, we believe that chemistry and science in general would have a huge role to play. So we will definitely try our best to organize events of this nature as things may reveal. So with that, we would like to thank once again everyone who had gathered here today for this event, and please stay tuned for our activities. Section E2 has been organizing a lot of activities up to date, and we hope to continue the momentum going forward as well. We will be organizing a lot of in-person events to enlighten the audience in terms of the scientific aspects, and also a lot of webinars will be in place as well. So please stay tuned, join us with our future activities. Most of the updates will be shared with you in due course. So on that note, thank you very much once again, Professor Ravi. Thank you very much for being here, sir.
Okay, thank you very much, Rahir, and all the very best, and my thoughts, wishes and prayers are with everyone in Sri Lanka, and I wish you all hopefully a peaceful and prosperous new beginning coming soon. So all the very best, and thank you for listening to me.
Thank you very
much. Take care.
Thank you very much. We have taken a lot of your valuable time. So thank you very much for being here, sir. And we definitely look forward for your cooperation in future as well. Thank you, sir. So with that,
bye.
Bye, sir. With that, we have come to the end of this webinar. Have a very pleasant evening. Hope to see you again with our future activities. Thank you very much.
Thank you.
Thank you, sir.
Thank you. Bye.